Hi guys and gals, this is Mike Dixon from BSD Code and Design Academy, and today we're going to talk about rigid bodies in Unity 3D. Now basically a rigid body attached to a game object just means that that game object will behave the way we would expect it with real world physics, meaning that it will fall due to gravity, it'll get pushed by forces such as wind or getting punched for instance. It'll simulate also between two objects that have box colliders on them, or any type of collider for that matter, in a realistic way that we would expect. So they can be super useful. If our game has anything to do with physics, I highly recommend trying to leverage some of the power of Unity's rigid body system. I think it'll go a long way and it'll get you the look that you're really going for. So if we take a look at this scene that I have set up, it's pretty basic. It's basically the Unity default scene with our main camera and directional light. And you can see that then I've added a plane that we're going to use as the ground for this demo and a cube that's floating in the air. Now the cube does not have a rigid body component attached to it. We can see over here on the right hand side in the inspector, meaning that if I click play, it's not going anywhere. It's just going to float unrealistically like that and not care that there's gravity in this scene right now. So the way that we're going to handle this is that we're going to have the cube selected, choose add component over on the right hand side and choose physics and then rigid body. Cool. So now right off the bat we should be able to hit play and see this cube fall. Awesome. But we should also note that it doesn't just fall with gravity, but if I were to create another cube, another boring cube, this one's going to be under the first one, but just barely kind of, just so we can nick it. You'll see that this box collider that's attached to my rigid body cube is going to collide with the box collider with my normal default cube, and we'll get sort of an interesting thud. Cool, right? And that actually gives it a little bit more life, right? The fact that it kind of bumps that gives it a little extra direction and force and creates a really nice effect. So now one thing with beginners especially is they get frustrated with rigid bodies because they feel like they're floaty, like they don't have the right mass to them. Well, this can be often an issue having to do with the size of your rigid body. For instance, if I were to take this same cube here and scale it way up, then even though gravity is going to have the same effect on it, its perceived speed is going to be much slower than before. So let's click play now. Boom. And you see it falls, it feels very heavy, very slow, like a building falling down or something like that, on a much different scale than our original block. Bam. Very cool. And likewise, if I were to scale it down, smaller than the default, which is 1 meter, let's make ours 0.3, 0.3, 0.3. It's really tiny. I'll lower it down a little bit and move it over our other blocks so that once again it just nicks it. I just use the F key to zoom in on that. That's a great tip if you don't typically use that. So then I hit play, and bam. Now it should feel a lot more like a brick, like a ball of lead or something like that. Bam. And even though it's not actually falling faster, there's this perceived weight when it does react with other objects that makes it seem a bit more realistic. Now, just a couple more things for this demo. There's some options that we can use by default without using any code, although I love using code. There's some options right here in the settings for rigid body that can affect the way that these behave with each other. The one that I'm going to focus on right now is drag. Drag simulates air resistance, meaning that it will fall a little bit slower if the drag is higher. So let's do one quick control just without the drag. This is drag 0. And it falls, and yeah, it sort of looks like maybe a wooden crate or something like that would fall. And then let's take this cube and give it a drag of, how about 8? And what we'll see is that it's actually going to fall lighter. See that? It takes longer to fall. It takes longer to tip. We get some more angular momentum going on with the spin, but ultimately it lands gently, kind of like a balloon filled with helium or something like that. Just sort of floating down. So I encourage you to get in there, try some of these settings, try some of these constraints. There's lots of interesting things that we can do. And remember, scale is huge when we're dealing with rigid bodies. The bigger items are going to fall, or appear to fall, much, much slower than the smaller items do. And I think that's going to be a big part of making a realistic game. Will be making sure that your scene is in a realistic units, right? So that you're actually using real world measurements, because that's what Unity is using to do the calculations. So that's it for rigid bodies right now. In our next video, we're going to add some scripts and things get really interesting. This has been Mike with BSD Code and Design Academy. See you next video. That's it for this time. This has been Mike Dixon with BSD Code and Design Academy. Be sure to check back here for more tutorials. And don't forget to check out bsdacademy.com to learn more. See you soon.